In this video, we're going to look at the learning target. I can solve a system of equations, including a line, parabola, and circle, by using substitution. Now, before we look at two specific examples, I want to talk about what substitution means in math. Okay, substitution is like what happens in a basketball game, right? So if you imagine you have a basketball game, typically there's 5 players on the court for one team. So if I draw out the 5 players here, okay, so imagine this is my team. And then on the bench for that team, I might have a few players there as well. Okay, so I have 5 guys in the game, and let's say I have 2 players on the bench, and I want to do a substitution. Well, what happens is one of the players comes out of the game. Okay, so I take a player out of the game, and then a person on my bench goes in for that player that came out of the game. Okay, it's a substitute. They come in as a substitution. Mathematical substitution means exactly the same thing, except for we have one additional criteria. The substitution can only happen if these two people are equivalent, meaning they're equal to one another. So, like, let's say this player that was originally in the game was 6 feet tall. Okay, so this guy's 6 feet tall. In order to do the substitution, this individual would also have to be 6 feet tall. They have to be equivalent in order to substitute. So if we keep that in mind, let's go ahead and look at number one. So in number one, I have y equals x plus 4, and I have the equation y equals x plus 2 squared minus 4. I want to solve this system. Now remember, solutions to a system are ordered pairs. They are points. Okay, so I want an x coordinate and a y coordinate. I want an ordered pair that makes both of these equations true. Okay, it works for both of them. So to do this, I'm going to solve this guy using substitution. I notice that in the first equation, it says y equals x plus 4. So I can take the x plus 4 and I can substitute that in for y in the second equation. Okay, so y, so to speak, is coming out of the game, and I'm replacing it with what it's equal to, which is x plus 4. So I get x plus 4 equals the quantity x plus 2 squared minus 4. And then I'm going to solve this guy for x. Now, I want to note that when we do the substitution, the reason why we're doing it is we want to eliminate one of the variables, so our equation now only has one type of variable in it. It only has an x. That allows us to solve for the x. Okay, so in this line, I shouldn't have any more y's. All right, let's go ahead and solve this. So I get x plus 4 equals x plus 2 squared. Now remember, x plus 2 squared means you're taking x plus 2 times itself. You're really taking x plus 2 times x plus 2, and then we're subtracting 4 from that on the end. When I multiply these together, I can use FOIL, so the first times the first gives me x squared. The outer, x times 2 gives me 2x. The inside, 2 times x is another 2x. And then last times last gives me 4. Okay, and I'm subtracting 4, and that equals x plus 4. Now, I notice that I have an x squared and an x, so this is in standard form, so I want to get everything on one side of the equation. So I'm going to minus x and minus 4. Okay, that leaves me with nothing on the left-hand side. And then on the right-hand side, I just want to combine like terms. So when I look at this, I have an x squared, but I don't have any others, so I'm going to write down x squared. I have 2x plus 2x, which is 4x, but I'm taking away 1, so I'm left with 3x. The positive 4 and negative 4 will cancel, leaving me with just this negative 4 on the end. Okay, so now I have the quadratic equation 0 equals x squared plus 3x minus 4, and I can solve this guy. I'm going to solve it by factoring, so I'm going to break this apart into the two binomials. X times x gives me the first term. Remember, the last times the last has to give you the last term. So to multiply to 4, you get 1 times 4 or 2 times 2. I need to get positive 3 in the middle, so I'm going to use the 1 and the 4. I need the 4 to be positive. I need the 1 to be negative. Okay, that gives me 4x minus 1x, which is 3x. Once I have my two factors, remember when we're solving quadratics, you can set your factors equal to 0 because of the zero product property, and then you just solve those. So in this case, I'm going to get x equals negative 4, and then if I add 1, I get x equals 1. Now, you got to be a little careful here. A lot of times students think they're done. We're not quite done. Remember, our solutions are ordered pairs. It's an x value and a y value. Right now, we just have x values. We need to find the y values that are associated with these x values. So to do that, we make another substitution. We take these x values that we got and we plug them back into one of our two original equations. Now, the first equation is a lot simpler, right? It's just y equals x plus 4. So I would probably use that guy to do this. So if I take -4 and I plug that back in for x, well, -4 plus 4 is 0. So my y is 0 when x is -4. Similarly, I want to plug 1 in. Well, if I plug 1 in instead, 1 plus 4 is 5, so I get a y value of 5. So my solutions, the ordered pairs, are -4, 0. The x is -4, the y is 0, so that's one solution. And then the other solution is the x is 1 and the y is 5. Now, if I wanted to check my answers, I could just plug these x values into the second equation and I should get the same y values. Okay. So for instance, if we check the second one real quick, imagine I plug 1 in for x. Well, 1 plus 2 is 3. 3 squared is 9. 9 minus 4 is 5. If I look at my y value, I have a 5, so it checks out. Okay, so you can kind of plug these back in to check your work if you need to. All right. Let's go ahead and look at the second example here. So in example 2, I have 2x squared plus 10x plus 48 equals y minus 10x. And then the second equation says -4x squared minus 16x equals y. Okay, I noticed this second equation is telling me what y is equal to. So I can take what y is equal to and I can substitute it in for y in the first equation. So I'm going to sub the y in the first equation out of the game, so to speak, and I'm going to replace it with what y is equal to. So I get 2x squared plus 10x plus 48 equals -4x squared minus 16x minus 10x in the equation. And once again, you'll notice when I do that substitution, I'm doing that to eliminate the y's. I should not have any y's left in the equation. Then, once again, I have an x squared and an x, so I want to get everything on one side. So I'm going to add 4x squared to both sides. I'm going to add 16x to both sides. And I'm going to add 10x to both sides. Okay, so I'm eliminating everything on the right side, so I'm left with just 0 equals. Then I'm going to simplify this side. Well, 2x squared plus 4x squared is 6x squared. 10x plus 10x plus 16 is 36x. And then I have 48 equals 0. Okay. Now, obviously, I'm working with big numbers here, but I noticed that each number, 6, 36, and 48, are all divisible by 6. So what I can do is I can actually divide both sides of the equation by 6 because 6 goes into every single term. 6 divided by 6 is 1, so I get x squared. 36 divided by 6 is 6, so I get 6x. And then 48 divided by 6 is 8. And then 0 divided by 6, well, 0 divided by anything is just 0. Okay, so all I did there is I just divided out a 6 so that I have easier numbers to factor. Then I want to factor this guy, so if I go ahead and factor it, x times x gives me x squared. The last times the last has to multiply to the last. Well, that's going to be 1 times 8 or 2 times 4. I need to get a 6 in the middle, so I'm going to choose the 2 and the 4. I'm going to make them both positive so that I get 2x and 4x gives me 6x. I set my two factors equal to 0 because of the zero product property, and then I just solve these. So I'm going to minus 2 from both sides, get x equals -2. I'm going to minus 4 from both sides, get x equals -4. Now, once again, I'm not done, okay? These are my x values. I need to find the y values that make up the ordered pairs, the solution. So I have to plug these values back in. Now, once again, I usually pick the easier equation, the one that's y is already equal to, so I'm going to use the bottom one here. And I just plug these values in. So if I plug -2 in, I'm going to get -4 times -2 squared minus 16 times -2 equals y. Well, using your order of operations, -2 squared is 4. 4 times -4 is -16. -16 times -2 is positive 32 equals y. If I combine those two, I get 16 equals y. So my solution here would be -2 is the x and 16 is the y. That's one solution. To find the second solution, then, it's the same idea, but I plug -4 in for both of the x's in the equation. So if I do that, and I'm kind of running out of space, so I'll try to squeeze it here. I get -4 times -4 squared minus 16 times -4 equals y. -4 squared is 16. If I times that by -4, I get -64. 16 times -4, if it's negative times negative, well, that's positive 64. -64 times positive 64 is 0. So in this case, the ordered pair is -4, 0. Okay, so my two solutions to this system are going to be the ordered pairs -2, 16 and -4, 0. And once again, if I wanted to check my work, I could take these numbers, plug them into the equation, and they should make both equations true.